On this problem, I'll start you off with what you're not allowed to do and why. It would be really tempting to just write this as 1/3 times the natural log of x cubed. The reason we're not allowed to do this becomes clear if we try to check our answer. We check our integrals by differentiating, and if we differentiate this, you would get the 3 times the 1/3 to cancel, and you would get left with the natural log of x squared. However, the chain rule would then say that we'd have to multiply by the derivative of the natural log of x, which is 1 over x, which is not what we started with, so the chain rule messes that whole thing up. So this whole idea gets a big frowny face. I might just move it somewhere over here, because what we really have to do with this problem is integrate by parts. This is technically a product of two functions that we're integrating, so that might suggest an integration by parts. The real question comes in trying to figure out what should our u be from our integrand and what should our dv be. Well, whatever we choose for u, we should be able to differentiate it, and whatever we choose for dv, we need to be able to integrate it. That doesn't leave us with too many options because integrating anything with a natural log in it is going to give us a more complicated result. So I think the only thing in this integrand that we can actually integrate would just be dx. That would leave us with just a natural log of x squared as our u. Okay, so let's go with that. Differentiating u is going to give us 2 times the natural log of x times 1 over x because of that chain rule again. And integrating dv and dx will just give us v equals x. Now we can use all of that information to rewrite this integral using the integration by parts formula. U times v is just going to be x times the natural log of x squared minus the integral of v du. Now, noticing that this x in the numerator cancels with that x in the denominator, we can rewrite this a little bit. And I'm running out of room, so I'm going to erase all the stuff that didn't work over here. And the integral that we're left with in this problem is the integral of the natural log of x. And I'm going to refer to the previous video in this playlist. If we can just use that result, we have our answer here. Multiplying that -2 through the parentheses gives us this answer right here, and I am going to call that good. If you want to see how we got this integral right here, I'll refer you to the previous video in this playlist. But stick around because we have some more good integration by parts problems coming. I'll see you there.